Okay, so 5.6, the last section in chapter 5, solving equations containing decimals. Move this on the way. So first problem is x plus 3.7 equal to 5.42. So if you want to solve for x, all we would do is subtract 3.7 from both sides of the equation. 3.7 cancels on the left. Then on the right, 5.42 minus 3.7 is 1.72. All right, any questions on that? Just do the opposite operation. We had a plus 3.7. So we get a minus 3.7, and then whatever you do to the left side of your equation, you do to the right side as well. And that's how you solve. Erase some of this stuff. All right, so the next equation, 2.4x minus 3.85 equal to 8.63. First thing we want to do, add 3.85 to both sides. 3.85 cancels on the left. And on the right, we have 12.48. So 2.4x equal to 12.48. Now to fully get x by itself, you divide both sides by the 2.4. So that 2.4 cancel. 12.48 divided by 2.4 is 5.2. All right, any questions? Make sure we're okay. So you want to make sure you show as much work as possible. I don't mind using calculators to confirm what you've done, especially on stuff like this. That's fine. Same thing here. You want to show work. If no more than showing this work here, show as much work as possible. All right. Erasing some of this stuff so we can walk through it. So the next problem is 0.03 times the quantity of x plus 4 equal to 0.01x plus 2.8. First thing we want to do is distribute this 0.03. And that gives us this result, 0.03x plus 0.12. All right. So now I have x on both sides of my equation. Your goal should be to get all of your terms with x on one side and all the terms without x to the other side. So I'm going to subtract 0.01x from both sides. Now, it doesn't matter which one you decide to move first. You have 4 different terms here. You can move any of them. It's up to you which one you move. As long as you stay correct with your mathematics, you still get the same answer. So I decided to move that 0.01x to both sides. To the other side by subtracting it from both sides. So that gives me a 0.02x plus 0.12 equal to 2.8. Now subtract 0.12 from both sides. All right, subtracting 0.12 from both sides will leave us with 0.02x equal to 2.68. Now to finish it off, divide both sides by 0.02. And you're left with 134. All right, questions. All right, don't let me scroll up. If you're still copying. Okay, so here we have the sum of a number and 7.5 is 3 times the number. Find the number. So when you look at what we have, there are going to be keywords and key phrases. I think we talked about this in this class already with just regular numbers. There'll be keywords and key phrases that will let you know how to set up your equation. So the first one is always, oh, hit the wrong button. First one is always the equal sign. You know, is your equal sign, or the same as when you say something like that. So you're looking at your equal sign being is, and then to the left of your equal sign and to the right of your equal sign can be broken up. So we're looking at to the left of our equal sign, it says the sum of a number and 7.5. Well, sum means add. So a number is our variable, so we're looking at x plus 7.5 to the left of that equal sign. And then to the right, it says 3 times the number. And that's what we have here, 3 times x. All right. Questions on the setup? All right. So from there, we'll go ahead and solve. I would subtract x from both sides because we need to get x on both sides of the on one side of the equation. So we subtract x from both sides so that it cancel out on the left, and then on the right, we will have 2x. On the left, we were left with just 7.5. To finish it off, we divide both sides by 2. And x is equal to 3.75. All right, questions. All right. So that's it for 5, 6. So questions on anything that I did and any of the processes that closes out chapter 5. So is everybody good? Some stuff or some questions may not come up till you actually try it out. If you haven't gotten to this chapter yet, section yet, then some questions may pop up. Always feel free to ask those questions during class, or shoot me an email on that. Let me see what 6.1 is not that bad, so we can. Yeah, it's only 3:20. We'll do some of chapter 6. Any questions before we look at 6.1? All right, so 6.1 talks about ratios. Just a comparison of two quantities. And it can be written one of 3 ways: A to B, A colon B, or A over B as a fraction. Most of the time, as far as the calculation, we'll be using it in fractional form, A over B. Give me a chance to write that. All right, so this first example says in class. In class, there are 15 women and 17 men. Write the ratio of women to men. So since there were 15 women and 14 men, women to men is 15 over 17. Writing the ratio of men to women, 17 over 15. Then they want us to write the ratio of women to the total number of people in the class. Let me make sure everybody can copy before I scroll up. All right. So the ratio of women to the total number of people in the class, you'll find the total number of people by adding 15 and 17, getting 32. Then you put 15 over that 32 as a ratio of women to the total number of people in the class. All right. Questions? Any questions? All right, next one says write each ratio in lowest terms. First one, we have 15 feet to 10 feet. So you would do 15 over 10, 15 feet over 10 feet. Those feet of measurement, those measurement of feet actually cancel out for us, and they're supposed to be in the same measurement because it's a ratio. So those feet measurement cancel out, and then we're looking at 15 to 10 to see if anything can cancel out of 15 to 10. And of course, that 5 would cancel, and that will leave us with 3 over 2 as our most simplest ratio. All right, $20 to $10. Same thing happens here. 20 over 10. Remember, the first number is always your numerator, second number is your denominator, 20 over 10. So it can reduce by 10, and that's a 2-to-1 ratio. All right, then the next one, 7.5 to 6.25. Now, we would first start off by doing 7.5 over 6.25 as a fraction. Don't forget, it's not in fractional form if you still have a decimal involved in your numbers. So I need to get rid of these decimals that are here. So the way we would do that is we look at how many decimal places we have in both cases. And here we have one decimal. Oh, get my pen back. Here we have one decimal. Here we have two decimals. So you multiply by the highest number of decimals and using that as a multiple of 10. So we would multiply both top and bottom by 100 because we have two decimal places here. If we had three decimal places, then we multiply by 1,000. So we can't multiply this one by 10 and multiply this one by 100. You have to be consistent in what you do. So if it takes 100 here and 10 here to get it to a decimal, then you have to do the whole 100 to cancel that out. So if you look at multiplying 7.5 by 100, that turns it into 750. Then 6.25 by 100 turns it into 625. So then I go ahead and break down both numbers here and then here. 750 times 750 is 75 times 10. Break that up into 3 times 25 for that 75, and then 25 is 5 times 5. So each one of these numbers are prime numbers. Break down to 10 into 2 times 5. So that's what this is right here. And so this is the process that you would take, and we talked about this when we were canceling out fractions before. This is the process that you take if the numbers are unfamiliar to you. If you don't see that 25 is a big number that can go into them, then you would break them down all the way into prime numbers. So in 625, I knew it was 25 times 25. If nothing else, you know there's a 5 that can go into it. So you can start off with just 5 if you need to. But then that breaks down to 5 times 5 times 5 times 5. And that's this breakdown right here. So then from there, you just cancel out whatever you have in common. So we have 3 5s that will cancel out with the top and bottom. I don't know why I did that one or not. Okay. And what it does is it leaves 5 right here and 2 times 3 up top. So 2 times 3 is 6, 5 on bottom, 6 over 5, or 6 to 5 ratio. All right. Questions? Any questions? All right, scroll up. All right. So here we have 2 1/4 to 3 1/2. Let me see, is this the last one? Yeah, it's the last one like this. So 2 1/4 over 3 1/2. Notice I wrote here, we're going to convert to improper fractions. That'll be the easiest way of handling this simplification. So 2 1/4 is going to be 2 times 4 plus 1. 3 1/2 is going to be 3 times 2 plus 1. You know, we keep the same denominator, so that'll be 9 over 4 and 7 over 2. All right, so then I'm going to put those back in there, 9 over 4 over 7 over 2. So I went from writing my divisional problem from being vertically to rewriting it horizontally. And so just writing that those two are the same thing, that division bar and that division sign are the same thing. And don't forget, whenever you're dividing by a fraction, you're multiplying by the reciprocal. So that's why I have 9 over 4 times 2 over 7. 2's cancel in the top and the bottom, leaving me with 9 times 1, which is 9. 2 times 7, which is 14. All right. Questions on that? Excuse me. Questions? Any questions? Let's see how much is in 6-3. I don't know about that. Are there any word problems? Oh, nope. So I must not ask you guys to do any word problems, so that's good. And that's percent. Yeah, okay. So let's look at proportions, which are your ratios just two ratios equal together? So proportion is a statement that two ratios are equal. So the example here is 2/3 equal to 12/18. So the first exercise you may see in this section says write a proportion for each statement. 5 is to 12 as 30 is to 72. So they don't want you to solve it or anything. They just want you to write it as a proportion. All right. Next one, the numbers -3 and 7 are proportional to the numbers -12 and 28. So once again, they're not asking you to solve in this exercise, just asking you to rewrite it as a proportion. You have two ratios equal to each other. That would be the answer. All right. Any questions? All right. So the thought process that's going to help us close out this section is cross products or cross multiplication. It says if A over B is equal to C over D, then AD is equal to BC. All right. So you always take your denominators up to the opposite numerator. So that's A times D equal to B times C. So if we take that first example of a proportion that I gave you earlier, 2/3 equal to 12/18, and cross multiply. In other words, take the denominators to the opposite numerators. 2 times 18 and 3 times 12 both equal to 36. So that's proof that this is a legitimate proportion. So if it is a proportion, then when you cross multiply, those two numbers will be equal to each other. All right, so I kind of already did the work, but it's all good. So they want us to determine whether these ratios form a proportion. So you would just cross multiply. 3 times 15 and 5 times 9 both give us 45. And since they are equal, that means yes, they do form a proportion. All right, let's see. I have the answer. All right, hold on 1 second. Guess I need to answer that since he's not leaving. Give me 1 second. All right, so never mind. I'll get somebody else to do it. I should be fine. All right, so the next one, 8/4, and we have 10/5.5. All right, so we got 8 times 5.5. 4 times 10. So I converted the 5.5 to 11 over 2 and multiplied, and that gave me 88 over 2. 88 over 2 is 44. And of course, over here, 4 times 10 is 40. And 44 does not equal to 40. So that's not a proportion. All right. Questions on either one of those? All right. Any questions? Any questions? All right. So let's use this to solve, and then we'll be done for the day. All right. So we have x over 13 equal to 6 over 39. We use the same thought process in cross multiplication, in which we will take the denominators up. 39 to times x, and then 13 times 6. So we have 39x equal to 78. Then we can divide both sides by 39. And 39's cancel out to give us 78 over 39, which is x equal to 2. All right. Problems with that one. So as far as proportions, it's always going to be the same process. You cross multiply, then divide by the number that's sitting in front of x. So when I look at 4 over 15 equal to 9 over n, if I want to solve for n, I'm going to cross multiply. I didn't need to do that. So I cross multiply, take the n up and the 15 up. So 4 times n is 4n, 15 times 9 is 135. Then I'll divide by 4. 4's cancel, leave me with just n on the left. Then 135, there should be a 4 right here. 135 divided by 4 is 33.7. All right. Any questions? Any questions? Got one more. Yep, one more, and then we'll be done for today. So they give us this problem right here, negative 12 over negative 8 equal to x over 2/3. So you follow the same process, follow the same procedure, even if it has stuff in there that you might not like fractions. So you multiply, take the numerators up to the opposite denominators. So it's negative 12 times 2/3, negative 8 times x. So negative 12 over 1 times 2/3, and if you just multiply across, that's negative 24 over 3. And so that'll be negative 8x equal to negative 8. And you can finish it off by dividing by negative 8. Negative 8 cancels. And you have x is equal to positive 1. All right, questions with the process? Concerns, anything, anybody? All right, okay, so that's 2. So what I'll probably do for this Friday is let it be a review day. So it won't be mandatory. I'll show up at 3 o'clock. But if you don't have any questions, you don't have to show up at 3. We wouldn't be doing any new material. I'll just be answering questions. So this Friday will be a review day. Once again, I'll be there at 3. If nobody shows up, I guess in 15, 20 minutes, then I'll know that nobody had any questions. But this Friday will be an optional review day for anybody who have any questions, and I'll be answering questions on anything up to that, that section. Yep, not a problem at all. Matter of fact, not just up to that section, you just have questions, period. Let's say you're moving ahead, you pass chapter 7 or whatever, have questions, feel free to come that day and ask them. All right. Any questions, concerns, or comments before we close out? Everybody good? Everybody straight? All right. Well, you guys have